Okay, now I want to show you something pretty amazing. As before, I have a virtual machine here, and the virtual machine is running on a virtual disk. And the disk I can just show you is it's vmdk slash. Okay, so I'll just do okay, so that's that one there, right? So this is the virtual disk. It's 50 gigabytes in size. Okay, and this is right into it. Now what I want to do is to be able to observe these changes to this disk as I'm doing it. I just want to show you something like that. So I can create a file on my desktop. Let's create a text document and let's call it Charlie. Charlie. Yeah, let's just call it Charlie. And so that should be there now. And now I'd like to be able to observe it. Now, it's a little bit awkward when two processes are accessing the same file at the same time. So, so I'm using a set of utilities. They're called the SleuthKit utilities, and they're able to access a file system without mounting it, and it's just a little bit safer. So I want to search for Charlie in this disk, and there it is. This file was just created this minute. Okay, let's say I name it to Charlie1. Let's see, I think I have to select that. So I go F2 and add make it 1. Yeah. Okay, so now if I do the same thing, you'll see it hasn't done it yet. There is a bit of a lag between these things happening. So I'll have to there it is. It's actually, that's interesting. So that's interesting. They're the same thing. This looks like this is deleted. That's what that symbol means. So it looks like when I did that, it actually created a new file. And SleuthKit can show you deleted files as well, and it usually indicates that by a little dash there. Okay, so that's something interesting that I've learned. Anyway, there is a bit of a lag, a couple of seconds between when a change happens to this and when it's written to this. Okay, now that's by way of a preview. So what I want to show you is some files in the prefetch directory. Now let's see if we can actually go to this. If I type /Windows /Windows. Oh, it's trying to connect to the internet. That's kind of weird. Okay, so let's go to computer, local disk, Windows. Okay, so one of these files here is called the prefetch, and I don't have permission to. I could click continue to get access to the. Okay, so here's a whole load of files here. A lot of PF files, extension PF. Now these are files that are used. They're used for information, but basically every programs that you run end up with an entry here. The name of the file followed by something that looks like gibberish followed by a PF file. Okay, so there's Google Update. In fact, the gibberish is basically an encoding of the path. So it looks like there's even more. 3 copies of Google Update for some reason. So you've got 3 different versions of a Google Update, and they've each been running here. Okay, so that's what this looks like. There's usually quite a number of files in there, and it's really an optimization strategy for Windows, but it turns out to be forensically very valuable. There was one there for MS Paint. Okay, and that's one I'm going to examine for the moment. So I can do a search for the paint prefetch file. Now there's a few paint things here, so I'm just going to also search for the just pf. Oops. Okay, so now this shows me there's the file there. Okay, and you should be able to see that's there. Now this number here is called the inode, and this is how I have to access that file. I could, for example, type that. So it's it's kind of awkward. I'll just do it. I'd have to put that there, and I have to keep this setting. I have to tell it it's the image. I have to tell it it's the offset into that image, and I'd need an icat. Now it's a binary file. Okay, so there's not much point looking at it. We could type it into XXT, and you see it's quite a big file. If I could also think I can do this file dash. Should we go to this? Will attempt to tell me what it is. And it's just saying it's just data. It doesn't actually recognize the type of file. Okay, so that's the file. Let's see. Then we want. Oh yeah. So what I'd like to do is to observe that directory as something happens. So I have a little, and I'm going to do that with the watch command. So watch minus d minus n1. So that means watch it every second, and what's it? FLS. Oh yeah. So this is going to just watch the prefetch directory. Okay. So it's actually only going to watch Paint or Notepad if either of those are modified, and so it shows you the time. So this Paint program, the modification time there indicates the last time this program was executed. So now I'm just going to run Paint here and just see what happens. So let's go to, oops, I better remove this in front here. Okay, so click on Paint, and Paint starts up. So let's change the size of it. Let's oh yeah, that hasn't changed yet. So let's click it. It usually takes a little bit of time, and then you should see this becoming 2019, and so yeah, see, look, it's changed there. 2019 or 2/28 and so on. Okay, so you can see the date that the paint was last run from this. Now, and so it's a handy artifact just from that reason, just the last modified time of the file. But you can also look at the file. Now we've already looked at it a bit, but I want to look at it a bit more, which is let's type ./sca. No, that's not the one. Oh, maybe yeah, I need this. Let's try this inode here. Okay, this, yeah, so this looks at the first few lines, well, the first 30 lines of this particular file, okay, in hex. So now I can use watch to do that, and I'll just do watch minus D, which just shows the differences. Okay, so now well, you might as well notice a few things. First of all, you can see the name of the file here, MS Paint. And you can see there's a dot after every second one. That's simply because MS Paint uses 16-bit Unicode. So when it's displaying normal ASCII characters, there's a dot. So the 4D00 is an M. 4D on its own would be M in ASCII, but with 16-bit Unicode, you get an extra set of zeros. So you see that the whole way along. The SCCA is the signature of a prefetch file. So that's the prefetch file. So an important point I want you to watch is this location here. Okay, this is actually a number, and it's in little endian format, which means you see the most significant two hex digits there, and then this. So this is 002. So it means that paint was run twice. That's what that location there. It happens to be 9, 8. The 2 bytes there are read 0002. Okay, so let's see if we can change that again. Let's run paint again. Okay, and let's kill it. Okay, so that should change to 3 in a second. Now let's do something else. Actually, I'll unhighlight that. Actually, I'll just highlight the one beside it. Yeah, I'm not certain if there's a lag or if every now and again it misses it if you don't run it for long enough. Oh yeah, no, there it is. Okay, so it's changed to 3. You saw a few other values changing as well. For the moment, I'm only interested in this 3 value. Okay, so you can see there's another artifact. So for programs that are run, the only problem with prefetch is that it's got a finite number of files that will fit in there. So I don't know what it is, maybe 128 or something like that. And then after that, it throws out the oldest one, so you lose some information. But it gives you a good idea of how many files were run, and of how many times a program was executed, for example. Now, it's fairly hard to interpret all this, so you think there's a better way, and there's a program called SCCA info, and and it'll process these prefetch files. Okay, so we just like to run that on the file. Now, unfortunately, let's see, there was so let's just try that on paint. Okay, so so I'll just show you that there's a little script I wrote, because it's basically I copy this into a temporary file so that I can then run this program on it, and I'm also doing grep minus Windows. So let's keep the Windows in. Okay, so this is what the output looks like. Now there's an awful lot of it. Okay, and you can see it maintains a list of files mostly. It maintains, see, that was a 3 if you remember. It tells you how many times it was run. It is the name of the file. It has some of the stuff. Okay, in addition to the last runtime. Okay, so what I did was, a lot of these files are less forensically relevant. They just contain windows. So if I just pipe that into grep minus v windows, it means don't display any line with windows in it. And now it becomes much more manageable. It does say 95 files there, because a lot of them were containing windows. Anyway, you see it's much more manageable. You see it's kind of civilized even. So I'm going to watch, that's the thing I'm going to watch. So that would be watch. Now I'm going to also specify a slightly different thing, difference. Okay, so it's going to maintain that, and the file I want is, oh no, that's not it, it was SCC paint. Oops, and I need one other thing. Oh yeah, it was this one here, I think. Was it? No. Okay, let's just, I think I do need that number. And just, oh, difference, yeah, okay, I have to spell difference properly. Okay, so now it's looking at the file and it's observing it, and it's doing that on a continuous basis. So if I make a change, I need to move this over here, I will be able to see it. I need to extend this. Anyway, some of those files are fairly long. Okay, yeah, okay, so let's go back in here. And I want to start paint. Okay, so let's just start paint. Actually, let's start it with this duck. Okay, so we start paint with this duck file, and then we'll let's save it. Is there a save as option here? Yes, save as. Let's save it as a new picture. Actually, maybe save it as a ping. Okay. Ooh, wow! Look what happened there. Suddenly, there's a lot more information. Okay, so there's the last runtime that's been updated, and now it's using extra. There's a lot of extra files here. There's Donald. For some reason, there's a whole load of extra Donald files in there. But in particular, there's this file here. This don't you? So these prefetch files can also indicate which other files you are using as part of the program. Now, they don't always come up, they're not guaranteed, but again, this is very useful evidence if you want to show that somebody was doing something. So the prefetch file is one of the most important artifacts on a computer system. So yeah, and generally you'd use a parser to analyze it and express it. So that's all. I just want to show you how you can observe the prefetch file in action, and how you'd use a parser. By the way, to find that parser is fairly easy. If you just type prefetch parser, and you'll come up with a lot of parsers. Okay.